Hello, my name is Einar Bjørgo. I'm the director of UNOSAT, the United Nations Satellite Center, based in Geneva and hosted by UNITAR. Very pleased to be able to talk to you here today about what our efforts are regarding satellite imagery for disaster and improved resilience. I'm going to share my screen just a second. So when it comes to the use of satellite imagery for disaster risk reduction, UNOSAT has had quite an experience in this over the years. And I'd like to also talk about some of the challenges they're facing or some of the solutions that have been developing. But firstly, about the United Nations Satellite Center, we have been operational since 2001 and recognized as this UN Center back in June 2001, sorry. And so when we had this mandate provided by UNECOSOC, it means also that we're focusing on, of course, helping the UN family with the satellite imagery analysis. So it's UNDRR is one agency that we're supporting, and also looking at how this can be coupled with training and capacity development. So we also work very closely with various member states in this in order to support them with solutions and capacities that they can use in order to make use of this technology. Very quickly, at the moment we have a headquarter in Geneva. Also very proud to say that we are hosted, our IT is hosted over at CERN in Geneva, which allows us to really have a very nice technical setup and making sure that we are always using state-of-the-art solutions when it comes to the development and the analysis of satellite imagery. But we also have various offices scattered around the world. I mean, we're a small agency, we're a small team. Overall, UNOSAT is about 50 people, but steadily growing. And we have what is, I think, more relevant to this meeting is a regional liaison office in Bangkok. But as I said, we also have projects in other places, and I'll get back to that. We also have a presence in New York as well. When it comes to our operational pillars, we are making sure that both the training and capacity development that we're doing are really rooted in needs. So we spend quite a bit of time in order to make sure that whatever solutions we develop are needs-based. And then we have also very experienced technical team that has been doing satellite analysis for many, many years. And we're also making use of this technology in applied research and innovation. And I'll get back to that. So what are the advantages of satellite imagery? So, of course, one of the main aspects I would say is really about it's vector information. We can also cover inaccessible areas. This is something that we saw during the COVID pandemic. How many people became aware of that. We hadn't really thought about it before. But now, having not the possibility to go to far away places, that was also something that really struck. Of course, we can also have near real-time information. There's really so many satellites up there. There are already quite a few, but in the years to come, imagery will be almost on at least 2-hour basis in terms of repeat frequency. And also access to the historical archives is important, especially for trend analysis, and that is very important when it comes to disaster risk reduction. But we can also use this to monitor situations as they go along. We also look at multiple applications: agriculture, environment, disaster management, population movement. We also work on conflicts at UNOSAT. But also new activities like project monitoring, etc. So another aspect, of course, is also looking at the conditions in the field. and also thanks to fact-based situational awareness. And then another important aspect I would also say is that, you know, the same information can be made available to all the actors at the same time, thus improving coordination. So this is just an overview of let's say, the main services that we are providing, and you can see that disaster risk reduction is a big part of what we are doing. We have food security, we have climate change adaptation. Many of these themes, let's say, are also sort of cross-cutting. They're going into each other as well, of course. So that is something that we are quite proud of, and maybe make those connections. I'll talk a little bit about the humanitarian mapping service that we have been providing for 20 years now. So this is a service that is, you know, really based on early stages of major disasters. There's often limited or incomplete and often contradictory information regarding the geographic extent of the affected areas, numbers and locations of affected population, who's in the most needs of assistance, and also when it comes to damage to housing infrastructure and transport facilities. The response capacity of local and national authorities is really something that we can help with through this facts-based information. And then also capacity and coordination and support for the international humanitarian actors. We work closely not only with the UN colleagues, but also with IFRC, NGOs, and others. So one of the main advantages of this technology, as I said, is that we can have it delivered very fast. And the one element that we are, or the one hazard we are working most on is flooding. So we have seen how this can be used in responding to emergencies, of course, but also on seeing how it can be used in detail updates and to the extent and impact of the flooding. We also provide identification of the location and severity of the damage, and we also detect possibility for secondary disasters, access to or how this, for example, affects health centers, schools, etc. And also we use the same to provide information about various so just let me show this video, it'll explain it. So typically it works that there are, and as I said, they're all based on requests. Whatever you request. So typically we get a request either by email or through the 24/7 hotline. This can come from various sources. And then we task the satellites. We also have excellent support from the International Charter on Space and Major Disasters. And then we download the imagery onto our CERN servers. And then our experienced analysts create the products and send this to the field. And then also, of course, so that the personnel can take direct action. So this is one example of that. This was the earthquake in Haiti. And we're seeing here one example. What you can see in the small dots is also information about the various damage levels here, you can see, and also how this affects the various communities. So typically the way we work is that we have one image before, one image after, and then we compare the two. So that allows us to be quite fast, and also through our experienced analysts able to make that available quite fast. I would also like to say that in terms of research, we have now, we're very proud of that, I have to say. We are having an algorithm that is running and using artificial intelligence. And this is something that we are making much use of these days. And we have, for example, here, what is important here is that we're able to fully automatize the process, so that whenever we we are able to run the algorithm, which has been trained by our own staff because we have lots of experience in that. Then we can have various information, and again, information that we have consulted with the various authorities on what kind of information do you need. Population exposed, the size of the inundated areas, and also the exposed population over time, but also to break that down into various administrative units, etc. We can then also link in information about schools, health facilities, etc. I would also like to spend a little bit of time in what we do in terms of enhancing climate resilience. And here we have a project that we're quite proud of called Common Sensing. It's been financed by the UK Space Agency. And this has been really a multi-year effort where we are working with also various UK partners and also the Commonwealth Secretariat. And this is a project aims to enhance climate resilience and strategic development for Pacific SIDS using satellite-based Earth observation data. So we have both focused on technical solutions, data cubes, and also capacity development activities here. So the various tools that we have been developing have been linked to climate, to food security, to disasters, and also an interesting aspect of this is access to climate finance. Now, in terms of access to current information, to strengthen really evidence-based decision-making, it is important to have that, to link land use and infrastructure information covering these areas. Also, access to the historic information that I mentioned, also access to future climate information. This is also something that is important because then authorities can see how they want to use this information, how they want to overlay with other type of ground data, and also understand the existing and future risks. So having a population, having various different tools to expose, to take informed decisions of this risk is something that we are also working on. So let me show you this video. This is really about a fictive case of a coastal community. And here we have been working together with the authorities to see how can we use this information. And there I have to also emphasize that this is, the authorities that are in charge here. It's not us. We provide the tools, and then the authorities use these tools. So what can be done to reduce the risk? So the tool can then provide you with various options depending on various factors that have been agreed to by the authorities. And also, I should say, the local communities, because they are also involved in this. So then when you do this, you will be able to compare and then, as I said, we are very closely with them, so it's not us defining how the various factors are important here. It's really up to them to decide. And then we simply develop the model based on various criteria. So it can be, distance to schools, distance to roads, health centers, so then you can see how this various factors can then be weighted. And then the tool will show you which areas are the most suitable. And then you can also compare the sites. So based on what the tool has suggested, you can then take informed decisions. So we have quite good feedback on this tool, and we have also trying to see how this is then linked together with climate finance proposals, and we are able to see how the authorities, because often in SIDS, as many of you know, they have huge problems in accessing climate funds because there's so many small countries. The demands to really show what is needed in terms of climate action for them to be able to have evidence-based information for their suggested projects is something that can be quite demanding. But we hope, and we have received excellent feedback so far, that the tools developed here are really, really useful for us. Just to finalize also, this is something that we have seen also quite a bit in various aspects of what we have been doing. Working closely with the Commonwealth Secretariat in this project, we are having what we call a pre-proposal phase. We have to identify projects. We have to have inputs for feasibility studies, prioritization of project intervention location. And then you get to the proposal phase, you see which areas are needed, which areas have evidence of historic climate change impacts for both the concept notes and also the full proposal. And then also, of course, also moving this into the project interpretation phase. So that is where we stand, and I think it's quite interesting. It's going to be really interesting to follow this kind of development in the future, and also to see how we can together help countries being able to have a more successful, let's say, proposals funded through the various funding agencies. So that was all I wanted to say. Thank you very much for your attention, and I hope that this was interesting. Thank you. Bye-bye.